Systems theory. So traditionally, especially in Western society, we tend to think of the way things work in a linear or chronological progression. But really, the way things work in the actual world, things tend to work in systems. So systems thinking has a prehistory in indigenous thought as the idea that all things are related. But as a formal scientific pursuit, it emerged only during the 20th century. Previously, Western scientists often assumed that they could understand systems by analyzing their component parts. So taking one aspect of a system, say it's the circulatory system of the body, and studying it independent of the rest of the body. And we know that doesn't really work, does it? If we have something wrong with our circulatory system, well, it's going to impact other things. If we have something wrong with our respiratory system, it's probably going to impact other systems within our body. So systems thinking recognizes the interrelatedness and the interdependence between the elements of a system and the workings of one system and all of the systems that are interacting with that system. So think of your own system, your own body. The boundary might be, say, your skin, but even so, there are things that happen that interact between you and the outside world. So you breathe air in, you exhale carbon dioxide. These are inputs and outputs we call flows. So things that move into the system and move out of the system. And then within our body system, we have all of these other systems that are interdependent upon one another. Our digestive system, our respiratory system, all of these systems working to keep our bigger system going. We interact in terms of family units, perhaps. And so a family, you might think of that as a system, and then you might think of a community as a larger system, and maybe a city as a larger system yet, and a country as a larger system. And all of these systems, ecosystems and political systems and social systems, are all existing within a larger system, the biosphere. So when you're thinking of systems, think about how everything is affecting everything else. So for example, if we think about the way the scientific method works now, you might study something like photosynthesis. But if you don't understand the tree within which photosynthesis is working, and the forest within which the tree is living, and the biosphere within which many forests and many ecosystems are existing, then you're not getting the full picture. So if you did the textbook readings, you probably know these terms already. Boundaries are the semi-permeable. It's important that we remember they're semi-permeable, so there are flows in and out of systems between the system and everything outside the system. Inputs are things like energy, maybe information, other materials that enter the system or move within the system. Outputs are things like waste heat or waste materials, maybe energy. Flows are things that move in and out of the system. Stocks are things like nutrients, resources, and other materials. And then we've talked about positive and negative feedbacks. So these are not elements of a system, but these are the ways that systems interact and work. So positive, we might think of that as a reinforcing feedback, and negative, we might think of that as a stabilizing feedback. So you've probably all seen something that looks somewhat like this. This is an example of a diagram of an ecosystem, and we have the predators on top, the little boy that's fishing and the heron, and then we have the fish that are being eaten, and we have larvae, and we have bacteria, and we have plants. So this is a simplified diagram of a particular system. But we can think of other things as systems as well. We can think of supply chains as systems. We can think of organizations and corporations as systems. And of course, these corporations and organizations, they all rely on everything working together for them to be healthy. But let's start with the human body, because that's something that we're all kind of familiar with. So, as I said earlier, the skin, we might think of that as the boundary between our system and the world around us, the other systems. And we have inputs such as air and food and water. We have outputs such as movement and work, waste, and other byproducts of all this. We have flows, breath in and breath out, stocks, energy that's stored in our fat cells, and then a couple of examples of feedback systems, or feedback loops rather. If we think about negative or stabilizing feedback, temperature control. If we think about positive or reinforcing feedback, an example might be depression. So here we have this fellow in the middle here, and he looks quite happy, but let's just say that he goes outside and it's cold and he's getting something from his car, so he didn't bother putting on a jacket, and so he's cold. How does the body respond? It starts to shiver, and that warms him up. So then he goes back into the house, and maybe the heat's turned up too high, and he starts to sweat. And sweating is one of the body's responses to heat, and sweating cools him off, and he comes back to homeostasis in the middle, and he's happy again. So these are examples of negative or stabilizing feedback loops that help to stabilize the system. Here we have someone who is experiencing a number of stressors in their life. And as a result of these stressors, their body starts to produce more cortisol. Now, cortisol is a stress hormone, and it's a really great hormone to have if you're getting attacked by a saber-toothed tiger. But if your body produces a lot of cortisol over a longer period of time, it can start causing problems. And this is one of the reasons that if you have stress in your life for a long period of time, your body starts to suffer various consequences as a result. So too much cortisol in the body can lead to insomnia. So this person has this increase in cortisol after these stressors have happened in their life, and now they're having trouble sleeping. And maybe some of you have experienced this. And because they've had a few experiences that are unfortunate, and they've got increased cortisol levels, and they're having trouble sleeping, they're starting to feel kind of negative about life. And so things that happen, they perceive as even more negative than they are. So they're feeling kind of crappy about themselves, or feeling kind of crappy about their life. So they stop getting up and getting outside and going for walks, and they're kind of staying home, and they're not visiting their friends as much as they used to. And they're starting to feel like, they just want to, curl up on the couch and eat Cheetos all the time and watch Netflix. And so they're starting to feel a decrease in physical health as well. And they're getting pretty owly and grumpy because they're not sleeping well, and they're not getting out, and they're not interacting, and they're feeling negative about their life. So their relationship is starting to suffer. And as their relationship starts to suffer, they're just finding it really hard to go to work in the morning. And so, their boss is like, well, I'm not going to give you as many shifts because you're not coming in for the shifts that I'm giving you now. And so their income status, their economic status is decreased. And all of this is leading to behavior change, and maybe their memory is starting to not work as well as it used to, and they're having trouble concentrating, and so they're stressed out, and so their cortisol increases and stays elevated, and they're still having trouble sleeping, and maybe that's really affecting them. And so you can see how this is a positive reinforcing feedback. It's just getting worse and worse. So that's how positive and negative feedbacks can work within our bodies. I want to talk to you a little bit about the Earth systems. So we could think of the Earth as a closed system. It has a boundary, and that boundary is the atmosphere. But do things move in and out of that atmosphere? Yeah, they actually do. If they didn't, we'd be in a lot of trouble. We rely upon solar energy input to keep the Earth a nice, toasty, warm temperature. And then we rely on terrestrial energy output so that we don't all bake to death. So some energy comes in and then some energy goes out. The energy that comes in is in the form of visible light. We see solar radiation when we look up at the sun and we see sunlight. And then that solar radiation some of that is absorbed by the Earth's surface, and some bounces back up. And some of that stuff that bounces up is trapped by the greenhouse effect. And some goes back into the atmosphere. And we have a pretty good energy balance right now. We've got this nice balance where our planet is within a livable range. Sometimes it might feel like it's too cold. Sometimes it might feel like it's too hot. But, we're doing okay. However, as greenhouse gases build up within our atmosphere, that causes the Earth's surface to heat up more because more heat energy is trapped within the atmosphere. And so that is what's causing the gradual increase in the temperature of the Earth. So right now we're at approximately somewhere between 215, 220 parts per million CO2 in the atmosphere. And carbon dioxide isn't the only greenhouse gas, but it's one of the primary ones. Back in 1800, we were at about 280 parts per million of CO2. So that's a pretty big increase. And that has been exponentially increasing since 1800 as our population has increased, as our industrial activities has increased, as we've produced more greenhouse gases, that number has risen. So almost by 50%. And that's a lot because if you go back in time, we had about 200 parts per million during the last ice age, and we haven't been at 415 to 420 parts per million for about a little over 4 million years. And the last time we were at 420 parts per million, the Earth was a very different place. There was life on Earth, but there weren't humans on Earth. And so that's the problem right there.